In this video, I'm going to go through the programming exercise 1 from chapter 10. This is to give you an idea of how these problems can be solved using objects and using object-oriented programming. I would encourage you to go ahead and stop this video now and try to work on the program before you watch the video. And then you can kind of go back and forth between watching the video and doing the work, just so you gain a better idea as to what's happening on this, okay? So this is on page 546. So this one we're asked to write a class named pet, which should have the following data attributes. Okay, so I've got in here my comment. I'm going to do a class pet, colon. Okay, there's no parentheses because it's not a function, doesn't take parameters. Okay, and the data attributes it's going to have, it wants a name with underscore underscore, so it's private, wants an animal type, and it wants an age. Okay, so we can, it's probably not a bad idea to put in here the data attributes, just so we have a list of them here. Okay, so we've got underscore underscore name. We've got underscore space, I guess, underscore underscore animal type. And we've got underscore underscore age. Okay. And then it has some functions that we're going to need, but we can work on that as we go along. So what we know we have to have is underscore underscore init underscore underscore that takes a self. Okay, self refers to whatever's calling it. Okay, and it says here that the init method should let's see, that should have an init method that creates these attributes. It should also have the following methods. Okay, so it creates them, but it looks like it doesn't do anything as far as default values. Okay, but we do want to create them, so we can just say that self dot underscore underscore name is equal to a couple of quotes. We could say self dot underscore underscore animal type also equal to a couple of quotes. You can put default values if you think that the problem needs it. Underscore underscore age. Let's put this at 0, okay, because the first two would be strings. This should be a float or an integer. Okay, it could be a float. Okay, so that's all it's going to do. Okay, we can test this. If you run this now, it's not really going to do anything, but it should let you know if you have any glaring errors. Okay, we run it. I'm going to call it pet, and it'll take .py by default, and it runs with no errors, so we're good. Okay. It's not a bad idea to get in the habit of putting in an end pet definition, just so you can visually see when we want to test it later. Okay, so the other things it asks us to do here, it asks us to do let's see, we've got accessors, and they do the mutators first, which is weird. So I like to do accessors first, so let's do those first. Doesn't really matter. So these are our accessors. Okay, and that's going to be the get name. It always takes a self, and since these are accessors, that's all it takes. And then it's going to return that self dot underscore underscore name. That's all that's going to do. Okay, in fact, the other two accessors are going to do exactly the same thing. Okay, so I can copy this, I can paste it and change those also for get animal type, animal type, and then for get age, which is going to return age. Okay, and again, we have to do this because the underscore underscore in the variable names means that they're hidden and we can't get to them directly. Okay, so now we have those three accessor types. Okay, and then we also want some mutator functions for all three of those. Okay, so the mutators are going to be define set name, which is going to take self, but this has to take a string with the name, so we can do an n for the name. Okay, and all the mutators do, you can go through and I said, at least in the last class, not to worry about error checking yet, But you could do it as instance here to make sure that n is a string and all that. But we're not going to do that yet. So we're going to keep it simple now. But keep in the back of your mind, eventually we have to check all this stuff. Okay. But if they set something correct, then we're just going to let self dot underscore underscore name equal to that variable n. Okay. And again, the mutators look very much like each other. So I can go ahead and copy those there. Okay. And then I can do a couple more of this. It's over and do a set animal type. So I'll call that in if you want it, but we can do a T for type. Make sure you change all the variable names or weird things will happen. Okay, and then on the age, so it's going to be a set age. Okay, and this one you can, if you want, do some basic checking. Okay, so if A is less than 0 or A is greater than, I don't know, 30. I know that like turtles get older than that, but in general, those look at pretty good ages. Okay, then we're going to set the name just equal to 0. We may want to do something else with it, but we're not going to worry too much about that. Else, we're going to set the self dot, it's not name, it should be age. Cut and pasting, you got to be careful. Make sure you change everything. Self dot underscore underscore age is equal to the A. Okay. So look at the problem. We now have the set name, the set animal type, the set age. We have the get name, the get animal type, and the get age. Okay. So once you've written the class, write a program that creates an object of the class and prompts the user to enter the name, type, and age of his or her pet. Data should be stored as the object's attributes, and use the accessor method just to retrieve the pet's name, type, and age and display that on the screen. Okay, so that's going to be our test program down here. Get that out of the way for the moment. Okay, so we're down here outside of the pet definition. We can define a main. Okay, remember that when the compiler starts, it's going to skip the class just like it would skip a function. Okay. So down here, I can say n is equal to an input. Enter your pets. Doesn't like that. Better put double quotes there. Enter your pet's name. Double quotes. Okay. And then we can do the T is equal to input type of pet. Okay. You may want some more explanation about that, but you don't have to. A is equal to an int input age. Again, I'm not worrying about doing the checking at this point. Okay. So now that I have those 3 bits of data, I can create a new animal. Okay, so I can say animal 1 is equal to, okay, or do the pet class. Pet 1 is equal to, I'm going to call the pet constructor, okay, and that takes no attributes currently, okay. We certainly could. Another way to do it is to set those up initially, okay, but it didn't really say what it wanted there. Let's see what it does say. That creates these attributes. Well, we could go ahead. Now that I'm reading that, it probably does want there to be a name, a type, and an age coming through here. Okay. So then we can set that to N, set that to T, and set that to A when we create it. Okay. That's may take us a little longer to create it, but that way we're going to create it. Again, the self just comes through no matter what, but we do the N, have to be in the same order, the T, and the A. Okay. So that's going to create it. Okay. So then we can see if this is working before we go any further. Okay. it's Rover, not Robber, it is a dog, and it is 3. Okay, so it's working. So again, when you're creating your test program, you want to test everything. So we're going to test our accessors here. And then we're going to print out pet1 dot get name, which takes no parameters, comma, pet1 dot get animal type, takes no parameters, but it does have parentheses, and then pet1 dot get age. Okay, that should just print that out. Okay, let's run this and see. So again, we've got Rover, dog, that is 3. Prints it out. Okay, we could probably make that nicer print, but we're okay. Okay, so now that's testing our accessors. Okay, so we can just, while we're doing that, since it's a test program, it's worth keeping track here. I'm going to test the accessors. Okay, and now we need to test the mutators. And again, for that, you could ask for a new name for the pet. But let's just go ahead and make the change here. Okay, so I'm going to do a pet1 dot set name. We're going to send it Rex, let's say. Okay, and a pet1 dot set animal type. I'm going to set it to a dinosaur. That's spelled right. Then a pet1 dot set age. We're going to send it. Let's send it something that's going to cause it to tear up. So hopefully, so if we do that, it should set it to 0. Okay, my cursor's doing weird things, but we'll figure it out. So we want to print it out again once we've made the change. Okay, let's see what that does. So I'm going to copy that, paste that. Okay, see what we got. Okay, so we've got Rover, got a dog, who's 3. It prints that out, and it also changes it to Rex, a dinosaur, who is 0 because 35 is wrong. Okay, if I make this a value that is correct, 15, run it again. Okay, so now we're going to get a different, well, let's say we're going to call it Fluffy Cat, who's 12. Okay, Fluffy Cat 12. And then it changes it now to Rex, a dinosaur, is 15. So I'm pretty confident that all of my functions are working. Okay, so at that point, you could, and for the homework, leave the test in. Okay, there's no reason to do anything else unless it specifically asks you to pop it up in a new program. But in general, to make this more usable, you would just delete all of that, and then you could include the pet into another program. Okay, so take some time to go through this to make sure you understand it, and I will deal with any questions that we have tomorrow.